So today, our main focus is to learn a second way to graph these. Okay, and you're going to find that sometimes finding the LR and graphing it using the LR is going to be the easier method. And sometimes this other way that I'll show you today will be the easier method. So what we're going to do is on this graph, I'm going to have us graph 3 separate parabolas. And I'm going to show it to you this new way. So the first one we're going to graph is y equals x squared. Okay? So if y equals x squared, where's the vertex? Where's the vertex at y equals x squared? 0, 0. Okay? Now I just want us to think about what the pattern is for this. So every time we go over one spot in the x, what happens to that value? What happens to your x value? It gets squared. Okay? So if you go over 1 in the x direction, what's your y end up being? What's 1 squared? 1. So your y ends up being 1. So here, if you go over 1, you should go up 1 and have 2 more points for your parabola that way. Okay, what happens if you go over 2 in the x direction? You end up going up 4 then, because 2 squared is 4. So if I go over 2, I should go up 4. And there's the parabola. We made XY charts before where we picked values for the x, but this is just thinking about what the shape of the parabola is and the patterns of it. So it's using the 2 ideas we've done combined. So this is the shape. So every time, if we have a y equals x squared, regardless of where the vertex is, every time we go over 1 in the x direction, we should go up 1 in the y. Every time we go over 2 in the x direction, we should go up 4 in the y. It doesn't matter where your vertex is. That's just the pattern of y equals x squared. So on this graph, we're going to add on y equals 2x squared. Okay, so what do you think that 2 should do to this graph? Should it make it wider or should it make it narrower? It gets skinnier, it gets narrower. So every time we think about what our x squared value is, we have to multiply it by 2 to figure out how high we should go in the y, right? So if we move over 1 in the x direction, what's 1 squared? 1, but we have a 2 out in front. So we really want to take 1 times 2. So we'd really go over 1 and up 2. Holy cow, this screen is shaking. There we go. I don't know. Okay. Now let's think about what happens if we go over 2. If we go over 2, what's 2 squared normally? 4, but we have a 2 in front, so we'd have to multiply it by 2. So we'd really go up 8. So 2, 1, 2, 3, 4, 5, 6, 7. Oh, a little bit off. And it'd be the same in the negative direction. So that would be our parabola for y equals 2x squared. Okay, let's put one more on here. Y equals a half x squared. Oh, that green's kind of hard to read. Let me make it a darker green. Yeah, we do. I need to figure out how to get the darker green set as one of my colors, I think. Okay, so where would the vertex be for this one? Same, it's still 0, 0.
So when you're doing your work, will it just like give you those 1/2 x?
Yeah, this is the equations that we're working off of. So now, what's this half going to do to it? It's going to make it wider. So when I go over 1, instead of going up 1, how much will I go up? I'll go up a half. So I'll go over 1 and up a half. It'll happen on both sides. It's going to be wider because this is a smaller number. compared to 2 and 1. Yeah. If I go over 2, normally we'd go up 4 because 2 squared is 4. But in this case, we have to times it by a half. So that would end up being what? 2. So we'd go over 2 and up 2. Same on the other side. So that would be our parabola. Okay, so that's the pattern of how they work. So if we know our perfect squares, particularly 1 squared and 2 squared, we should be able to just graph it thinking about the pattern of how that works. Okay, so I'm going to show you the graphs that we made yesterday in class, and we're going to see if the graphs we made yesterday followed this pattern. Okay, we made them using the LR yesterday. So let's see. Here was this one that we made. So what's the number in front of the value that's squared here? This is a 3. So that tells us when we go over 1, how much should we go up? 3. So let's see if that happens. So here's the vertex. So here we went over 1 and up. 1, 2, 3. Yeah, and that looks like where we ended up being. The other direction, over 1, up, 1, 2, 3. That looks like where we ended up being. Now this particular graph, do you remember doing this one yesterday? We had a graph 2 and a 12th, and then an LR of a third, and that was kind of difficult to do. So this new method, this other method of graphing it would be easier because we could just go over 1, up 3, put those 2 points there, and then draw in the parabola. Okay. This one. What's the number out in front end up being for this one? 1. Now we're turned sideways, but we still think about it the same. Instead of going over and up, you just think of going up and over. So here we should go over 1, and how many over or up? 1, and we do. When we go 2 away, how far away should we be? 4. 1, 2, 3, 4, we are. How about when we go 3 away? What's 3 squared? So we should be 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's pretty close. Okay? So that's another way to graph. All right, so we're going to do 2 examples together where we're going to get it in standard form. So we'll practice completing the square a couple more times. Okay? And then we're going to try graphing it using the pattern instead of using the LR and see how it goes. Well, we're still going to find all this information as well. But we're gonna try to graph it using the LR, using the pattern instead. And like I said, some of these, the pattern will be easier to graph, and some of these, the LR will be easier to graph. Generally speaking, the pattern is going to be easier to graph if you have a number like 1, 2, 3, or 4 out in front. As soon as you get fractions out in front, like a half, a third, a fourth for your A, then the LR is going to be easier. So it's going to depend on the problem. All right, so here we go. Y equals negative 3x squared minus 12x minus 7. So first off, we have to decide which standard form will we get this into it. Should it be a y equals or an x equals? Y equals. So our standard form that we want to get it into was y equals a times x minus h squared plus k. Okay, so what are we going to have to do first in order to try to get this into that form? Complete the square. So to complete the square, I have to take the negative 3 out of my x's. So y equals negative 3. Okay, so when I take the negative 3 out, what will I have? X squared, yep. Good, plus 4x. Blank, and then minus 7 can hang out at the end. Okay, so now I want to complete the square. Plus 4. And how do we know we have to add 4 on here? Good, we divide it by 2 and square it. So 4 divided by 2 is 2. 2 squared is 4. So we're going to add 4. And at the end, we're going to minus 4 and times it by the negative 3. Why did we have to multiply it by the negative 3? Yep, because we took the negative 3 out, so this 4 inside of the parentheses is also being multiplied by it. So y equals negative 3. Good, and then it'll be x plus 2 squared Good, plus 5, because this ends up being negative 7 plus 12. Okay. So there's our standard. So where's our vertex based off of this form? Where would our vertex be? Negative 2, 5 is our vertex. And we also are going to need to know for sure which way it's opening in order to graph it right away. So which way will this one open? Yep, this will open down because it's negative. So let's try graphing it using the pattern. Okay. So first we're going to plot negative 2, 5. Negative 2, 1, 2, 3, 4, 5. Okay, so now when I go over 1, how far down should I be going? 3. I should be going 3 down. So I'll go over 1 and 3 down. Over 1 and 3 down. When I go over 2, how far down should we go? Well, let's think about what's 2 squared. 2 squared is 4, and we'd have to multiply it by the 3. So 4 times 3 is 12. So when we go over 2, we should be going down 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, I almost ran out of space. So there would be our shape of our parabola. And then we could connect those. Ooh. So everyone okay with how we got the shape using the pattern? All right, so let's find all the other information.
I missed the last thing you did.
The 12? Okay, so if we go over 2, we have to think, all right, well, what's 2 squared going to be? 4. 2 squared is 4, and then we have to multiply it by the 3. 4 times 3 is 12. So when we go over 2 from our vertex, we should go down 12.
You always square it?
Yep, because the pattern is the x value is squared, and that's equal to the y value here.
How do you know that you go over 2?
We just go over from the vertex. So when we go over one spot from the vertex, how far down would we go? And then the next logical place to go would be over 2 spots. All right, so let's go through and name all this other stuff. So what would be the axis of symmetry for this parabola? Yep, x equals negative 2. And remember, the quick way to remember what the axis is, it's always the part that's in parentheses. It's always the variable that's in the parentheses, and whatever that one should equal. Focus and directrix. What do we need to find out to name what the focus and directrix is? Got 1 over 4a. So in this case, what's our a value? Negative 3. So 4 times negative 3. Yeah. So negative 112. So if we want to put our focus on here, our focus would have to be below our vertex, right? So would we add the 1/12th or would we subtract it? We'd subtract it. And which would we subtract it from, our x value or our y value? Yep, our y value, because we're going up and down. So our focus would be at negative 2, and then what's 5 minus a 12th? 4 and 11/12ths. So in the directrix, we would add it to. Our y's are the ones that are changing, so we'd say y equals. If we add 1/12th onto 5, what do we get? Yep, 5 and a 12th. And then the LR for this one, it's the absolute value of 1 over a. So what would the length of the LR be here? Yep, 1/3. So if you take a look at the graph, you notice here if we were to plot the 1/12th away really close, we'd have about a distance of 1/3 right there. Okay, so we would have got the same exact graph, but in this case, graphing that LR, because it's so small, would have been a little bit more difficult to do than doing the pattern. Is that okay? All right, let's do another one so we complete the square again. So x equals 1/2 y squared minus 4y plus 11. So x equals or y equals, which one? X equals, yeah. So our standard form would be x equals a, y minus k squared plus h. So how are we going to get it into that form? What do we have to do first? Take the half out. So x equals 1/2. If we take the half out of our y's, what will we get? Yeah, y squared. What when we take a half out of 4? Not 2, 8. Yep. Minus 8y. It's 8 because you have to think half of 8 gives you the 4. Okay. All right, so we want to complete this square here. So what will we have to add on? At 16. So at the very end we should minus 16, and what should the 16 be multiplied by? The half. And we got 16 because 8 divided by 2 is 4. 4 squared is 16. So we now have x equals 1/2 times, y minus 4 squared. Good, plus 3 because this ends up being 11 minus 8. So they're standard. So where's our vertex for this one? Not 4, 3. Let's see. Yeah, it'd be at 3, 4. Why is the 4 second here instead of first? Yeah, 4 is attached to the y, so we know that that's going to be our y value. Which way should this one open? Up, down, left, right. Yep, this one opens to the right. How do we know it's to the right? Yep, it's x equals and it's positive. So let's try to graph it using the pattern. So start at 3, 4. For this one, whatever's inside the parentheses here, so the y and the 4, so that's got to be the y coordinate. So that means 3 is our x coordinate, so it would go first here. Okay, so for this pattern, when we go 1 away, normally 1 squared is 1, but here we have to times it by the half. So what would that be? A half. So when we go 1 away from our vertex, keeping in mind we're opening to the right, we have to go a half. Okay. When we go 2 away, what's 2 squared normally? 4, but then we have to take the 4 and times it by a half. So that would be 2. So when we go 2 away, we're 2. And then we could take those and graph it.
So you times half by 4 to get the bigger point by big
Well, what's 1 squared?
Oh.
1. And we take half of that, so a half. So we go over 1 and we just move a half.
Where'd you get 1 from?
Because we're going 1 away from the vertex. So we're going 1 away from the vertex, we move a half. Here we go 2 away from the vertex, we move 2. Okay, so now let's check out with the other information. So what would be your axis of symmetry here? So what's in the parentheses? 4, and what variable? So you'd say y equals 4. Okay, focus and directrix. We need to figure out what our 1 over 4a is. So what's our a value for this one? A half. So 4 times a half. Yeah. So a half, 1 over 2 is how far away we are. So our focus here, we're a half away. So I want to move that to the right. So which one am I going to add that onto? My x or my y coordinate? Yeah, my x. So 3 plus a half is, 3 1/2, 4 is our focus. Our directrix, since we're changing the x coordinate, we're going to say x equals 2 1/2. Good, because we'd subtract it off. And then we need the LR, which is the absolute value of 1 over a. A is a half here, so what's 1 over 1/2? You just have to flip it. 1 divided by a fraction just means you flip it. So this is just 2.
Right. I've never seen that in my life.
1 divided by a half. 1 divided by 1/2. Instead of dividing, you multiply it by the reciprocal, so we get 2. Okay? So here at the focus, is that a distance of 2? At the focus, was that a distance of 2? Yes, it is. Now for this one's probably either method for graphing works about the same. But once when you get to like the problem that's like a 1/6, like your first one, the LR method's really going to work best. Because it's going to be hard to go over 1 and only up a 1/6. Okay, it's going to be hard to estimate. All right, so now I'm going to give you a couple pieces of information, and you're going to write the equation. Okay? So here, I'm going to give you what the focus and the directrix is, and we want to figure out what the equation is. So here the focus is at 2, 8, and the directrix is at y equals 4. So the focus is at 2, 8, and the directrix is at y equals 4. What do you think would be a good starting point if we wanted to figure out what this equation was? Yeah, well, that's the first thing. We need to figure out if it's y or x equals. How are we going to figure that out?
Well, the directrix is y equals 4, so it's going to be equal to x, right?
Okay, so that's one way. So you can look at the directrix and pay attention to the chart and then decide from there. The other way is why don't we just graph both of these and see what it looks like. So 2, 8, 2, 1, 2, 3, 4, 5, 6, 7. So there's my focus. My directrix is at y equals 4. 1, 2, 3, 4. So which way should this open? Not down. It should open up, because the focus should always be inside of our parabola. So just by graphing those two things, we see that this should open up. So if it opens up, which standard form are we going to use? Y equals a x minus h squared plus k. So to write the equation, we need two things. We need the vertex, and then we need to know what a is. How can we find the vertex? How could you find the vertex? Well, how did we graph the focus?
Wait, how do you know it's opened up?
Because it's opening up because the focus has to be inside of the parabola. The directrix has to go below it. So this is the only way how it could work is if it opens up.
So
The focus has to be inside of it. So if you open down, the focus is not inside of the U anymore. It's outside. So it's got to open up. So how do we know how to get to the focus from the vertex? Oh, it's y equals, it's opening. This has to open up, right? So if you open up, look at your chart. The directrix is y equals, it's an opening up one. Okay.
This is the hardest I've ever done in my life.
It's not though. Think about focus and directrix. Let's go up to yesterday, the first thing we talked about. Okay, we talked about this. No, you're looking at the axis of symmetry. We're given the directrix. Okay, so let's look at this. The focus and the directrix, how far away are they from the vertex? Are they the same distance?
Yes.
Okay.
Find the midpoint between.
So, if this is the focus and that's the directrix, where would the vertex have to be? Right in the middle. So where's going to be right in the middle? Go up 2 from there and label that the vertex. So what point is that at? 2, what'd you say, 2, 6? Good. Okay. So the other thing we need to know is the A value. There's a way to find it. Here, I'll go back up. What did we say the distance was between the focus and the directrix? Or the focus and the vertex? 1 over 4a. Okay, so let's look at what we have. This distance should be 1 over 4a. Well, do we know what that distance is? It's 2. So let's make an equation. 2 equals 1 over 4a.
So if you have your vertex first, how would you find your...
So how are we going to solve this? Times by 4a. So we have 8a equals 1. So a is 1/8. Now we just have to plug our a value and our vertex into our form. Okay, so we have y equals, what do we get for a? 1/8. X minus 2 squared plus 6. Okay. How would we finish graphing this? Because it also asks for the graph. How are we going to know how wide we are at the focus? 1 over our A? Well, what would be 1 over 1/8? 8. So we should have a total width of 8 at the focus. So how far over should I go? 4 each way. So 4 that way, 4 that way. Connect it.
That's jumpy. Are we going to be able to do that or no?
Yes, you have to be able to do this. Yep, we'll do it again. This time I'm going to give you the... next time I'll give you the focus and the vertex. We good? Yeah? Okay, so this time we have the vertex is at 5, -1, and the focus is at 3, -1. Okay, so graph these. So the vertex, 1, 2, 3, 4, 5, -1. Focus, 3, -1. Which way is it going to go? To the left.
The focus has to be inside.
The focus has to be inside of the parabola. So it's got to go this way. It's got to go left. So x would equal a y minus k squared plus h. So what are we missing then from the formula? We have our vertex already, so what do we need to find? Just the A. That's all we need to find is the A. We already have the vertex. No, we don't need the directrix. We just need to find the A because we're asked for the graph. Because we're just asked for the equation for the graph and to graph it itself. So we have the HK because we have the vertex. So what can you tell me about the distance between the focus and the vertex? Okay, it's 2. So the distance between the focus and the vertex is 2. And what should that equal? Not just A, 1 over 4A. Well, that looks an awful lot like the equation we just solved. So what does A equal? 1/8. Because we just solved it in the previous problem. I mean, we just solved this equation in the previous problem, so we can solve it again, but I'll help you solve it again if you need help later. So now, how are we going to write this as an equation? So we have our A, we have our vertex, we need to put it into our formula. So x equals, well, which way are we opening? Negative 1/8, because we're opening left, times, good, y plus 1 squared plus 5. How wide should we be at the focus? What's 1 over 1/8? 8. Same thing we just did in the last one. So we should go 1, 2, 3, 4 away, 4 away, go from the vertex to the end. There's our parabola.
I'm trying to do another problem.